Hello, Knox County. My name is Mrs. McMurray. I am a fourth grade teacher at A.L. Watts Elementary. Hello to all my students. I love and miss y'all. I am a math demonstration classroom teacher, and I am excited to be here teaching at home. I mean, this is great, so I hope that y'all are excited. We are going to be going over fourth grade Unit 2 information, hopefully to set you up well to dive into the math in action task that you were provided with. It has been emailed to you. You can also find it online at knoxschools.org/KCS at home. And you can also find a paper copy of these packets at our food distribution sites. So we're excited about this. So we'll jump right in. We are going to start with the challenge answer from Mrs. Whaley. If you watched the Unit 1 review with her, you were presented with a challenge at the very end. It was a lot of toilet paper, a lot of rolls of toilet paper, and I'll show you that picture here. And I'm wondering, how many pieces of rolls of toilet paper do you think there were? Do you think there were more than 1,000? Less than 1,000? Well, here's your answer. Are you ready? Drum roll. 960 rolls of toilet paper. 960. That's a lot of toilet paper. Whew. So we'll jump on into our information for Unit 2. So we'll get going. So in Unit 2, we talked about a lot of things. And it's been a minute since we covered Unit 2. We talked about understanding multiplication. What does multiplication mean? Really diving into understanding not just I know 2 times 2 is 4, but why. We talked a lot about the multiplicative comparisons. That's a mouthful. All that means was that times as many as. So 3 times as many as 4 is 12. Because if you have 4 3 times, then you would have a total of 12. We moved from there to multiplication and division word problems, really looking at just some basic problems there. Then we moved into multiples and factors, which is really where we're going to spend our time and effort today reviewing, because it talks a lot about that in that math in action. Then we talked about number and shape patterns, which, looking at this, you're like, how do patterns fit into all of this, into algebra and operations? But what's neat is multiplication really is a pattern, that repeated addition. So that's in there as well. And then last but not least, those multi-step word problems. Multi meaning the prefix more than one. So you have to solve one thing that unlocks you to be able to solve the rest of the problem. So sort of like a puzzle. So like I said, we're going to focus in here on reviewing factors and multiples. We're also going to talk a little bit about prime and composite as well. So like I said, so you're ready for your math in action. All right. So the first thing that we're going to talk about is multiples. So when you think about multiples, you're thinking about your skip counting. If I say the multiples of 3, 6, 9, and so on and so forth. I tell my kids that you could skip count to the moon, because you can always just continue to do that repeated addition. So I say that there are many multiples as a way for us to remember. So again, a multiple would be the product that you get when multiplying a number. So let's say I pick the number, we'll say 4 here in just a minute. If you continue to do 4 times 1, 4 times 2, 4 times 3, those are going to get you your multiples. Like I said, it's sort of like it's your skip counting, your repeated addition. So we're going to do some quick examples here just to refresh your memory. So we will start with this first question, and we're going to rotate around this way just to get some practice in. So we're going to talk about the first 5 multiples of 4. Often I'll tell my kiddos that we probably wouldn't ask you to list all multiples because that would take some time to write every single multiple. So usually your question will say something like, what are the first 5? Or is this number a multiple of that number? So we'll dive in. So the first 5 multiples of 4. Well, the first multiple of 4 would be your 4 times 1, and that's simply 4. So 4 would be that first multiple. As we move through, we'll say 4 times 2. Well, I know 4 times 2 is 8, so that would be our second multiple, okay? And then 4 times 3, anybody know? Been working on those math facts? That's 12. 4 times 4, any guesses? Can I hear it? I miss my students. 4 times 4 is 16. And then last but not least, 4 times 5 to get you 20. So as I'm thinking about my multiples would be these products, just like what we talked about up here. So your multiples would be, let's write them over here, 4, 8, 12, 16, and 20. Those would be your multiples. Again, that repeated addition. So I've got these really fun cubes that connect. So really, again, just to show that repeated addition, this would be 4 one time, which is 4. 4 2 times, which get you 8. And then 3, 4, and then 5 times. If I had the number 4 5 times, that's going to get you 20. So that really represents those multiples. All you're doing is skip counting that repeated addition. Okay, so as we move on to our next one, we'll kind of get reset here. And then our next one will be the first 5 multiples of 6. So if I'm asked to list the first 5 multiples of 6, remember we are going to start with 6 times 1 because 6 is a multiple of 6. I feel like that's kind of a common thing to forget, to include that first one, so don't forget that. Then we'll move to 6 times 2, 6 times 3, 6 times 4, 6 times 5. Then we'll go down and multiply. So 6 times 1 was 6. 6 times 2 will get you 12. 6 times 3, 18. 24. 30. Hopefully you've been working on those math facts. That's a great thing to be practicing, working on that fluency over this break. So we'll have our multiples of 6 here. We could list them out: 6, 12, 18, 24, and 30. Those would be the first 5 multiples of 6. Okay, awesome. Y'all are doing great. Then I'm wondering, it's similar to those true-false questions that we'll often have on a quiz or an assessment. And it says, is 32 a multiple of 9? So is it a multiple? Meaning, could you multiply 9 times something to get 32? I'm wondering. So as I'm thinking, I'm going to think out loud. I'm wondering, is it a multiple? Could I skip count by 9 to get to 32? Do thumbs up if you think yes, thumbs down if you think no. Give you just a second there. So I'm thinking that if I say, well, I know that 9 times 2 is 18. I do know that. So, maybe I could add another 9. Could I skip count again? Well, 9 times 3 is going to get me 27. Okay, maybe I could do one more. I'm wondering. But 9 times 4, though, is going to get you 36. So is it possible to skip count by 9s to get the 32? It's not going to be possible. So is it a multiple? It's not a multiple. So we could record our answer here and say, no, 32 is not a multiple of 9. And we could explain our thinking here, saying that, 9 times 3 is 27, and 9 times 4 gets you 36, and 32 is in between there, so it's not possible. So it's not a multiple of 9. All right, last thing on multiples really quickly. I'm wondering if you can figure this out. It's a little bit of a puzzle. This says multiples of blank. I'm wondering what all of these numbers could be a multiple of what? I'm wondering. We have 30, 9, 12, 3, and 24. 30, 12, 24, 9, and 3. I'm wondering, I could get these as a product if I multiplied them by what? How have to be the same? Any guesses? Well, if I'm looking at this top row, there could probably be a couple different answers maybe, but really as I look at all of these, what number would be a multiple of all of these? I'm thinking about this 3, and I'm wondering, could you say 3 times something to get 30? Well, we could. It'd be 3 times 10. Could I say 3 times something to get 12? Well, we could. We could do 4. And then 24, 3 times something to get 24. Well, that's going to be 8, okay? And then 9, 3 times what gets you 9. You could also think about that in the inverse of 9 divided by 3. That's going to get you 3. And then last but not least, you have 3. 3 times what gets you 3? Well, that's just 1. 3 times 1. So what this is proving is all of these products, all of these numbers are all multiples of 3, right? So if we came back over here and said, well, these are all multiples of 3. Great job. Hope you're feeling great about multiples. We're going to jump into factors. Awesome. So factors are super exciting. They are whole numbers that multiply together to get a given number. So let's say we're going to talk about, we'll get down here to this number 10 here in just a second. But really how I like to tell my kiddos, it is a factor times a factor to get a certain product. So let's say I want to know all the ways that you can multiply to get 12, or all the ways you can multiply to get 10. Those would be the factors. What times what could get you a specific number. One quick note through your math in action, or different things that you'll be working on. You might hear the term factor pairs. Well, think about a pair of shoes. How many shoes are in a pair of shoes? There are 2, right? So a factor pair would simply mean 2 factors together. That's all that means. So sometimes you'll hear people talk about factors or factor pairs. Again, just to clarify, the factor pairs are just 2 of those factors together. So as we jump in here, if we had a question that said something similar to list all the factors of 10, all the factors of 10, all the numbers that you could multiply to get 10 as your product. So what I like to tell my kids, I think sometimes it's tempting to jump around and say, oh, I know 2 times 5. I think it's helpful, especially as we work with some bigger numbers, asking for find all the factors of a larger number, like 32 or something like that. It's really helpful to go in order to figure out if each number is a factor of that specific number. And I'll show you what I mean here in just a minute. So this says list all factors of 10. So I'm going to come over to my whiteboard here, and I'm trying to get 10 as my product. So what I like to do is go in order and just say, okay, well, 1 times what could get me 10? 2 times what could get me 10? 3 times what, and so on and so forth. And I'll show you kind of how this works. Well, so we know this one, we're going to start off nice and easy. Well, 1 times 10 is going to get you 10. That means that 1 times 10, that would be your factor pair, and 1 and 10 are both factors of the number 10. Well, this one's nice and easy too. 2 times 5 is able to get you 10, so that means 2 times 5 would be another factor pair of 10, and 2 and 5 are also factors of 10. Now, when we get to 3, I'm thinking about my 3s. I'm going to skip count by 3s. 3, 6, 9, 12. Well, I jumped right over 10. So is it possible to multiply 3 times a whole number to get 10? It's not possible. That means 3 is not a factor of 10. So we'll keep going. What about 4? Can I skip count by 4s and get to 10? 4, 8, 12. Well, then again, I skipped right over the number 10, so I can't do that. 4 is not a factor of 10 because you can't skip count by 4s to get to 10. Then we have 5. 5 times what gets you 10? Well, do you notice that we've already hit this factor pair, that it's repeating because we already know that 5 times 2 or 2 times 5? It makes me think of that commutative property. It doesn't matter the order that you multiply because you're still going to get the same product. So when you hit that repeat, that is your signal to say that you are done finding your factors or your factor pairs. So we found them. Our factors of 10 would be 1, 2, 5, and 10. Great. And I like to list them up there like that. So those would be your factors of 10. So we can do the same thing with the factors of 12. We can do the very same thing. So we'll jump and do this pretty quickly. So if I'm saying, well, 12, what are my factors of 12? I could say I know 1 times 12 is 12. That's going to work. 2 times what would get you 12? That has to be 6. Ooh, 3 times what? 3 times 4, that's going to get you 12. Man, so all of these are factors so far. That's great. Then I'm moving down to 4 times what? Did you notice that we've already hit that factor pair? Once we've already hit that factor pair, I know that I'm done finding all my factors. And then you can simply list them. 1, 2, 3, 4, 6, and 12. Okay, so those would be your factors of 12. These would be your factor pairs of 12. Okay, moving right along. So I'm wondering down here, is 4 a factor of 30 or 20? Is 4 a factor of 30 or 20? Well, if I'm thinking about that, I'm thinking that, 4 times what, could get me 30, or 4 times what to get me 20? Because for it to be a factor, I need to be able to multiply something to get 20, 4 times something to get 30. Now, I hope that this maybe jumps right out at you with your basic math fact there of 4 times 5. 4 times is going to be 20. And here, again, if I skip count by 4s, 4, 8, 12, 16, 20, 24, 28, 32, I can't multiply 4 times a whole number to get to 30. So that means that I know that 4 is a factor of 20, but it is not a factor of 30. Okay? Awesome. Last factor question here. So this says, what number is a factor of every whole number? So this is kind of why I love math. It's just crazy all the patterns and different things that you run into. But if you think about that, what number would be a factor of every single whole number out there? Every single one will always have what as a factor? Can you think about it? It's going to be 1, because you can always multiply 1 times itself to get itself, if that makes sense. You can always say 1 times something to get that something. So pretty cool to think about. So 1 is a factor of every single number. Nice job. Y'all are doing great. All right, our last review before we jump into our math in action task, we are going to be talking about prime and composite. Now, we moved from factors into this because it has to do with factors. So we'll talk about prime first. Prime simply means there's only one factor pair, one in itself. Sometimes you'll hear it said of only two factors or a factor pair that's meaning the same thing. So if we look at this, my example that I thought about was 11, because the only way that you can multiply some whole numbers to get 11 is 1 times 11. So that's the only factor pair. Now it's the same thing with 2. 1 times 2 is the only way to multiply, or 2 times 1, to get 2 as your product. So that means it's prime. What's cool about 2 is that it's the only even prime number. What I like to remind my kiddos of, it's not about even or odd with prime and composite. You can have an odd composite number or an odd prime number. It's not about even or odd, it's about the number of factor pairs. But if we look at composite, composite simply meaning there's more than one factor pair, so more than one way to multiply to get that whole number. So as we talk about 4, I'm going to think about, well, I know that 1 times 4 could get me 4, and also 2 times 2. Those would be my 2 factor pairs, so I have more than one factor pair there. On 12, there are a lot of factor pairs on this one, and we did it earlier, so we could say 1 times 12, 2 times 6, 3 times 4. So those would be your factor pairs of 12, making it composite because there's more than one, if that makes sense. So there is also one little piece of trivia, interesting information here. There's a number that's neither prime nor composite, and that number is 1. It's not prime and it's not composite, because technically the number 1 only has one factor. 1 times 1, that's one number. There's only one factor, so it's neither prime nor composite. So we'll jump in to our task. For today, I want to just talk about a couple of quick things to set you up well for that. So what I've done, I recreated the graphic that is on your Math in Action page. And it's talking about pine cones and needles, which is a really cool thing. I've got a lot of pine trees in my backyard. Maybe you could go find some in your backyard. Do a little bit of research. So, cool stuff. We are given a task in this packet, and what I want to be sure to tell you right now, parents and families, there's not just one right answer. That's why it's more of a task. There could be more than one right answer. So if you're working through this at home and thinking, well, what's the right answer? Well, there might be more than one. That's kind of how it presents itself in a task. So as you look on your packet on the pine cones and needles, it looks like G.O. is with his friend Azul at a wildlife park, and a worker at the nature center is arranging the pine cones and the needles in pairs, meaning in groups of 2, for display. And there are some rules, there's some boundaries here. So the rules are, number 1, one length has to be a multiple of the other length. So you have to be able to skip count by that length to get to the other length. The next rule, the longer length cannot be more than 5 times the shorter length, which we'll talk about that here in just a minute. And then this last little bit might be a little tricky. It says cones or needles can be paired with other cones and needles. So you don't have to match cone length with cone length. It could be a cone length with a needle or a cone. You can match any of these numbers. That's why I did these on Post-it notes so we can move them around and talk about them. So what we're going to think about is on your next page, G.O. had a solution, and he said he already knew that the length of one object in a pair has to be a multiple of the other object. So one length is multiplied by a factor, factor times a factor, to get your product, to get the other length. He could think about any two numbers in this table. I need to find pairs in which one number is a multiple of the other. So he's gonna make a chart. So what he did, and I'm thinking that he said, okay, well, I'm gonna start with 5. 5 is a nice, easy number to multiply. So I've got my 5, and I'm gonna put it on the shorter length side. And then he's gonna say, well, 5 times what could get me one of these numbers? Well, I know that 5 times 5 times 2 would get me 10. So you could think about it that way. And if you look on your Math in Action, they actually have that one recorded as well. 5 times something to get 10. I know that 10 is a multiple of 5. I could skip count to get there. We could say that 5 times 2 could get me 10. So that would work. Let's keep going and say, well, what about 4? I know that 4 times 6 could get me 24. I know that 24 is a multiple of 6, so that could be a pair. So 24 being that multiple of 4, that would work so far. Well, then I also have, maybe I'll try 8. If I have 8, 8 could be my shorter length. Well, I could also say that 8 times 3 could also get me that 24 centimeters, which would also work. And then I also have, we could also say that 5 times 3 to get you 15. I'll put that 5 back up here for you. So even as you notice, like as you're looking at your Math in Action page, your chart might have different answers than the pairs that we found. There's more than one right answer here. But what's neat is that he said, I know that 4 times 6 would get me 24, which is right so far, but we've got to go back and think about those rules. It had to be no more than 5 times. So this would be the only one that would not work in that scenario. This one would not be a good pair because of this times 6. Remember the rule, it had to be less than 5 times as many. So that one wouldn't work, but all these other ones would. So you could go back and look and say, okay, my first pair, I knew that this was the cone length for the jack pine and the needle length for the sugar pine. That could be a pair. That's why they listed it down on the bottom there. You could also just go through and say, okay, well, this was the ponderosa pine cone and the 24 and the cone length of the longleaf pine. So lots of different pairs that you could think through there. There's not just one right answer in this. So I hope that you enjoyed that. I have a little bit of a challenge too. I'm going to show you a video and then I'm going to show you a picture, and I want you to think, what do I notice and what do I wonder? What do I notice and what do I wonder? And I bet you're going to think, how many are there? And maybe I'll tell you the clue or the answer next week on the Unit 3. So I hope this was helpful in your Math in Action, and way to go for working hard on math. And I hope to see y'all soon. Bye.